You started? Okay, so lesson 50, quadratic equations. Now, so far you've learned to solve equations, quadratic equations, by factoring, right? That's what you know so far.
Yes.
We're going to learn a different way of solving quadratic equations by completing the square. Now, let me go back a little bit. Completing the square. And I ask you, what is a perfect square? Does anybody know?
Perfect square is a square that has four sides that are equal. Okay.
When we're talking about equations left, and a perfect square is comes out of this. If I have x plus 2, for example, and I square it, do you remember that this is x squared plus 4x plus 4? Let me change this. Let me put a 3.
6x.
Plus 9.
Very good. 6x plus 9. You remember that a perfect square has, if I divide this by 2 and I raise it, I get this number. That's how you find it. That's a perfect square. Give me another perfect square. Would this be a perfect square?
No. Oh, yes.
It is. What would this be?
X plus 4 square.
X plus 4 squared. Right? Does everybody see that?
Yes.
What would this one be?
X plus 6.
X plus 6 squared. Does everybody understand that much? Yes. Okay. So, what are we going to do?
Wait, miss.
Yes.
An easier way you can do is 6 times 2 is 12, and then 6 squared is 36.
6.
That's exactly what tells you.
You'd always get the same answer.
Exactly, always.
And you can,
So you discovered the pattern. That's exactly what it is.
Can you do it the other way? X plus 3 times x plus 3, like that?
You can, but that's the same thing. So you discovered the pattern. Very good. So keep that pattern in mind because you're going to do this.
Scared face, guys.
Woo.
Scared face.
Okay, so they tell you, solve this by completing the square. So what do? You leave this. What did I do?
Leave the.
That's all I did. I moved the 4 to the other side, and now I have an incomplete square. What can I add here to complete it as a square? Come back to us.
X.
9. Add 9.
Yeah.
Why 9, Seth?
Because when you 3 square is 9, and 3 times 2 is 6.
Very good. So I divided this one by 2, and that gave me 3, and I raised it, and now I get a perfect square here, because this would be x
Plus 6
plus
square.
3
3 square.
squared. Does everybody see that?
Yes.
Yeah.
Equals 4.
Yes, people.
Why can you do that?
Because you can. Why can I do that? Because if I add 9 on one side, I add 9 on the other. And I can always add 0, can't I?
Yes.
That's the one thing I can always add. Just like I can always multiply times 1. In this case, I added 0. Why? Because if I subtract 9 here, 9 minus 9, 0. So all I did was add 0. Do you agree?
Yes.
Why can I do that? Because I can always add 0.
Where did you add 0?
So that I can complete the square. Oh, why would you want to do that? May I finish?
No, I understand why you want to do that, but I don't understand how you could just magically put 9.
I can't. It's not magic. If I put 9 here and I put 9 on the other side, I can always do that. I could put 13 here and add 13 on the other side. And what am I really adding? 0. Can't I always add 0 to something?
Mm-hmm.
There you go.
And now we go square root.
So now I can square root this, and I've got
X plus 3 equals square root of
Ian
X plus 3 equals square root of 13.
Plus
equals
minus.
plus minus square root of 13. Does everybody agree?
Yes.
So X equals
So
negative
x
3.
because my objective in all of this always is
Find
what?
X. Find X.
It's to find x. It's to solve for x. So
Negative 3 plus minus square root of 13.